So now we're ready to move on to the next part of the lab. So you should have already completed questions number 1 and 2, which were the topographic map questions. Now we're going to move forward into identifying the features in real topographic maps, as well as interpreting those features. So in this section of the lab, it's pretty straightforward. In question number 3, we have right here, okay, it says below, but the printing ended up with the map on the other side. One of the features listed, cirque, horn, aerate, trow, came, drumlin, or esker, is in this map. Now, a lot of students in lab didn't read the directions. You're only looking for one member of the list on this map over here. Then you have to identify, is it erosional or depositional features? And do a similar thing for these two maps. And stop and think before you try to find the features. Remember, glacial features tend to be clustered, so they'll all be either erosional features or all be depositional features. And you have to ask yourself, are we talking about a mountain environment or are we talking about some kind of plains environment? Because think about what we learned in class. What kind of glacial features are we expecting up in the mountains? What kind of glacial features are we expecting to be deposited on the plains? So I'd like you to work on those questions, basically questions 3 through 10. And let's take an opportunity. In the transit home, my pause and think got a little blurry, but take a moment, pause the video, pause and think. Give you a few moments to do that. Okay, so hopefully you've answered the questions. You took the time to answer the questions. I know at least, I've been teaching for a while now, I know at least some people are just following through and go, oh, Dr. Evie just gave me the answers. I'm the smart one. But stopping and thinking about the answers first is very important. You learn more deeply. So, the features that we find right in Burr Mills, okay, basically next to the Burrville cider mill, are drumlins. So these long features in here match up to our drumlin topographic map that we predicted over on this end. Drumlins are depositional features. And then over here, there were a whole range of features. So we have a trow over here and a trow over there. We've got an aerate. This isn't the only aerate in the map. We've got cirque right here, cirque over here, a whole bunch of horns. These are not the only horns here. So if you identified other than those horns, that's perfectly correct. Question 7 is already answered here. So if you're looking at the trow, remember, ice, just like rocks, just like water, okay? It all moves down. Everything's moving according to the force of gravity. So this is down in this valley, so the glacier moved down this trow in this direction. Remember, you might be thinking, oh, but that's up on the map. It's not up. It's north, okay? So that's north on the earth. The glacier flowed north. So then looking at this question down here, this is a map of the Chub River out in the Adirondack Mountains. And we can see that this is a big, wide, U-shaped valley. And the Chub River is this itty-bitty river, teeny tiny river. That teeny tiny river didn't carve that big, there we go. That teeny tiny river didn't carve that big old valley, right? So it must have been a glacier. And that valley is a U-shaped valley, or what's called a glacial trough. And then finally, how would glaciers appear in the rock record? There's 2 ways we would expect glaciers to show up. We can see the sediment till, and we would expect them to destroy underlying rock layers, okay? Because they're powerful forces of erosion. When we move into lithostratigraphy, we're going to see what's called an unconformity, which is a gap in the rock record. And glaciers, very often, that's our record of glaciers in the rock record, these huge unconformities where the glaciers destroyed rock. And we also saw that on our field trip as well, right? Where we talked about what bedrock is at the surface. We have this Ordovician, this 480 million year old bedrock around us. Well, what happened to the dinosaurs and everything in between? All of that was ground up by the glaciers as the glaciers moved through. So we are ready to move on to part 2.